In this video, you will learn about a completely different type of proof. Sometimes when we get to these two-column proofs, there is no way for us to directly prove the conclusion that we would like to reach. So up until this point, we've always been proving something directly. But now we're going to learn how to prove something indirectly. Now, indirectly, there are some steps that we must follow in order to complete these proofs. We always start with some sort of opening, and in this opening, we start first by saying what our two possibilities are. So we always start with either, and then usually we write what we are trying to prove, or the opposite of what we are trying to prove. Those are really the only two possibilities for proofs. Either what we're trying to prove or the opposite of that is true. Only two possibilities. Then, after we have our either statement, we next say, let's assume the opposite of what we are trying to prove. So let's assume the opposite of the proof. And then we kind of begin our proof from there. So we start by assuming whatever the opposite is of what we're trying to prove. And this is where it comes in as being indirect. So we're going to try to prove the opposite. And to do this, we usually do some sort of paragraph proof. So you're going to set it up now very similar to a paragraph proof in the body, and you keep going through that paragraph proof until you reach a contradiction. And once we reach that contradiction, we write but, so we kind of stop our paragraph proof and we write but this contradicts. And usually we're trying to always contradict a given. So this contradicts the given that states, or usually we write the given that's being contradicted. So we stop our paragraph proof, we say, but this contradicts the given that, and kind of fill in that blank. And then we can say, so our assumption was false. Because it contradicted that given, then that means our initial assumption was false. And then to conclude this proof, we usually write therefore, or sometimes instead of actually writing out the word therefore, you might see these three little dots. That also means therefore, whatever we were initially trying to prove must be true. So we cannot directly prove it, so we assume the opposite of it, and then we try to prove that, and then we reach a contradiction. So that's the basic setup of an indirect proof, and in order for you to get full credit, you're going to need to have each of these steps. So this is going to make a little bit more sense once we go through an actual example. So let's take a look at this example. Now, some things that indicate to me right away that this is an indirect proof is that I have one of my givens that says that AC is not congruent to DF. And angle B, we're trying to actually prove that angle B is not congruent to angle E. So right away, whenever you have that something is not congruent or not a midpoint, things like that, that should indicate to you that this needs to be set up as an indirect proof as opposed to a direct proof. So we already kind of have the outline, the template set up for you, and you just need to fill in the blanks. So here's our opening. Either angle B is not congruent to angle E, because that's what we're trying to prove, or angle B is congruent to angle E. Those are the only two possibilities for our conclusion. Either the angles are congruent or they're not congruent. So then let's assume the opposite of what we're trying to prove. So let's assume that angle B is congruent to angle E. And once you assume that, that's a part of your proof. So you can go ahead and then put tick marks on your diagram there. Angle B and angle E are congruent. And then this is where we kind of begin the paragraph proof from here. We want to try to contradict one of the givens, and typically it's always the one that's not congruent. So somehow we want to eventually get segment AC to be congruent to segment DF, because that would contradict a given fact. So we know these two givens, so I always copy the givens that are congruent. So from the givens, angle A is congruent to angle D, and segment AB is congruent to segment DE. And now looking at the diagram, we can prove these two triangles are congruent by angle side angle. So, triangle ABC is congruent to triangle DEF by angle side angle. And keep in mind, we're trying to contradict one of the givens. The only given we haven't said yet is that AC is not congruent to DF. But now that I know the triangles are congruent by angle side angle, then AC must be congruent to DF by CPCTC. So therefore, AC would be congruent to DF by CPCTC. And this is where you kind of stop your proof, because you've reached that contradiction. So, but this contradicts the given statement that AC is not congruent to DF. No, that's a given fact, that they are not congruent. That was in our givens. So therefore, our initial assumption must be false, and our initial assumption was that angle B is congruent to angle E. So that means this part must be false. So therefore, angle B is not congruent to angle E. Because when we assumed that they were congruent, we reached a contradiction. So this is what you're going to kind of do, and it kind of takes a couple examples to get the hang of it. So move on to the next video and we'll go through a couple more examples of indirect proof.